There's a bee right now on one of those flowers everyone comes across, or on a lavender plant, just perched on a stem with its tiny yellow and black body. Its wings are still, but its legs are moving. Then it suddenly takes off and just vanishes from sight. You watch it, but a second later it's flown out of your mind. You just brush it off as a little bug. It makes honey, pollinates the flower, and then flies away. But it paused and did something right there on that lavender plant. And that something was actually far beyond what you might have imagined. Because in that brief pause, which seems meaningless to you, that tiny bee had actually made a decision. It performed a calculation there and transmitted information. And right now, that information is actually being processed in a hive hundreds, perhaps even kilometers away. A scene you might have thought was quite ordinary and simple was in fact a small part of one of the most complex communication systems. Tonight, as you turn off your lights, the bees in your garden will be holding an extremely precise planning meeting. Some are adjusting the hive's temperature down to the centimeter and working to maintain it. Others are identifying diseased larvae and isolating them before they turn into a larger outbreak. And still others are endlessly debating which flower to visit at the crack of dawn. Welcome back to my Bees Around As channel. Before we start the video, please subscribe and stick around until the very end, because the fifth point we'll cover will show how an entire colony functions like a single brain, and it has the power to completely change your perspective on nature. So let's jump right into our first point. 1. Bees can give directions, and in 3 dimensions, no less. That bee you always see in your garden didn't actually end up there by chance. Someone gave it directions, but these directions don't involve a street name, a sign, or a map. It might sound strange, but it's just a dance. When a worker bee finds a food source, it returns to the hive and simply begins to dance on the comb. This is actually called the waggle dance. It traces the shape of the number 8. The direction of the line in the middle of the 8 encodes the angle of the destination relative to the sun. Distance is encoded by duration. A waggle lasting about 1 second roughly corresponds to 1 kilometer. The third dimension is quality. The richer the source, the more exuberant the dance, and the longer it lasts. For a poor source, the dance is subdued and quite short. For an exceptional source, it's practically a celebration and a festival. But watching here doesn't just mean seeing and understanding. The hive is dark, and sight alone isn't enough. That's why the observer bees move closer to the dancing bee and touch it with their antennae, directly sensing its vibrations. In other words, direction, distance, and quality. These 3 pieces of information can actually be conveyed simultaneously through both sight and touch. It's like when you're giving directions to a friend. You might say, "Head this way," or even send a screenshot. And all at once, in a single dance movement, they can convey the distance in kilometers relative to the sun's position and the value of the source to hundreds of observers touching one another with their antenna in a dark room. Carl von Frisch studied this system in depth in the 1940s and was awarded the Nobel Prize in 1973 solely for deciphering this language of the bees. For so many years, many scientists refused to believe it or acknowledge its existence. After all, it was hard to imagine that an insect could carry out such a complex form of information transfer, but the data consistently yielded the same result. A brain the size of a coin developed this system millions of years ago, long before GPS existed. The hive falls silent, yet the outside world remains still. But inside, everything is communicating and processing information. 2. Bees can distinguish both human faces and each other's faces. Of course, when you first hear this, you might naturally be skeptical. Because we have a strong intuition about brain size. The smaller the brain, the smaller the cognitive capacity. But research has repeatedly shattered this intuition. In controlled experiments, bees were shown photographs of different human faces. Those that correctly identified the face were given sugar water, while those that made mistakes were not. The bees grasped this distinction, and their success rates reached astonishing levels. Scientists believe this indicates that the ability is not simply a matter of rote memorization. Bees break a face down into parts to recognize it, and, conversely, can process it as a whole. This is called holistic face processing, and for a long time, it was actually believed to be unique to mammals. It's not limited to the human face. Every colony has its own unique chemical signature, a distinctive scent composed of propolis, beeswax, and a mixture of thousands of other components. When a worker bee returns to its hive, the guard bees at the entrance can immediately identify it by this scent within seconds. If the signature matches, it's allowed to pass. If it doesn't, it's barred and must stay there. No matter how innocent a forager from another colony may seem, it absolutely cannot cross that boundary. In other words, the hive operates with an invisible passport system. We don't yet know for certain whether the bee that visits your garden can recognize your face, but it can very clearly determine whether you're familiar, a stranger, or a threat, and it carries this information back to the hive to process it there. 3. Bees vote, and their decisions are almost always correct. Let me start by saying this. When spring arrives, a large colony splits. Half of the bees leave with the queen, and this swarm is called a swarm. The swarm first settles on a nearby branch or tree and waits. But what are they waiting for? A decision on a new nest. Also, at this point, scout bees naturally come into play. These bees explore the surroundings, measure and evaluate potential nest sites, tree hollows, cracks, wall cavities, then return and dance. Different scout bees propose different locations. Each one dances for the site it has found. The dance for a high-quality site is more enthusiastic and lasts longer. Other bees watch these dances, go to inspect the sites themselves, and return. The dancers for a high-quality site grow in number over time. The advocates for a low-quality site gradually dwindle, and at some point, they stop dancing altogether. Ultimately, the entire swarm settles on a single location. Uncontested, silently, by unanimous consent. Here's the thing. Researchers have observed that the decisions made through this process are at least as good as, and often better than, those made by human experts. There is no leader. There is no bullying. Just the flow of information and the natural emergence of strong arguments. A hive is both a deliberative assembly and a voting booth all at once. If one day you see a swarm of bees settle over your garden, they are on the verge of establishing a new colony. 4. Bees medically treat and maintain the health of their own colonies. What I'm trying to say here is that this is probably the least you've heard about it. Because when we think of medicine, we always picture brilliant minds, advanced equipment, and years of training. Yet bees have been protecting their colonies from disease for millions of years without any of these things. Now, let me also point out that it all starts with propolis. This resinous substance is collected from plants, pine buds, poplar trees, and brought back to the hive. For a long time, it was thought to be merely a structural material. But propolis is also a powerful antimicrobial agent. Studies show that the bacterial and fungal load inside a hive coated with propolis is significantly lower. When bees coat every surface of the hive with this substance, they are essentially creating a massive antiseptic environment. They do this automatically, continuously, and without stopping. But of course, the story doesn't end with propolis. If a small animal, a mouse or a worm, enters the hive and cannot be killed, the bees mummify it with propolis. They stop the decay. And what's more, it has been observed that some bee species detect diseased larvae by scent, distinguish them from healthy larvae, and remove them from the hive. When the disease burden increases, the colony spontaneously reorganizes its division of labor. Without anyone giving orders, the system detects the threat and responds. The hive is a much more sterile and much more intelligent place than it appears from the outside. 5. A hive can be thought of as a single organism. In particular, everything we've discussed so far, dance language, facial recognition, democratic decision-making, medical intervention, all of these seemed like individual abilities. But the bigger picture is this. These abilities do not come from separate individuals, but from a single whole. Essentially, a bee colony behaves as a single organism. This is called a superorganism, and the term isn't just an abstract metaphor, it attempts to describe a biological reality. A colony maintains the hive's internal temperature with half-degree precision to survive the winter. This is something no single bee could do on its own. But thousands of bees function like a heat sensor. Some generate heat by vibrating, others cool the hive by flapping their wings, and together, without any leader, they achieve the optimal temperature. The hive behaves like a living being that regulates its own body temperature. Of course, generally speaking, when spring arrives, the colony decides to grow. But who makes that decision? It's not a specific bee. When a threshold, determined by the combined factors of the colony's food supply, the number of larvae, seasonal information, and external weather conditions, is crossed, the entire system shifts in unison. Individual bees don't see the big picture, but the colony does. Let's not forget this. That little bee that visits your garden every day, it's not alone. Behind it lies a decision born of the collective intelligence of tens of thousands of bees. That bee is a cell of an organism. And that organism, right now, at this very moment, is thinking. To give an example, do you remember that bee hovering over the lavender? We've come full circle. But now that scene looks different, doesn't it? That bee had encoded its sense of direction. Hundreds of meters away, in the hive, bees processing this information were performing a decision dance. In that same hive, an engineer was regulating the temperature, and a doctor was monitoring the larvae. And all of this, without anyone giving orders, without anyone planning, was functioning as parts of a single whole. As you can see, the scene of the empty box was full. It was always full. You've been living right next to it for years. Now you know. Now I'd like to ask you, have you ever noticed a bee lingering unexpectedly for a long time on a flower or a branch? What went through your mind in that moment? I'm waiting for your comments. See you in the next video.